Hey everyone, and welcome. Today we're going to talk about something called risk-based inspection. Now I know it sounds a little technical, but trust me, it's this incredibly smart way that we use data and forecasting to keep our industrial world from, well, falling apart. Let's dive in.
Okay, so take a look at this. A massive storage tank, right? This thing could be holding thousands, maybe millions of gallons of something really important. And the one thing we know for sure is that over time, it's gonna corrode. So here's the million-dollar question. When do you inspect it? Do it too late and boom, you're looking at a catastrophe. But do it too often and you're just burning through time and money. So what do? There has to be a better way.
Well, for the longest time, the answer was kind of clunky, honestly. We just used a calendar. Let's just check it every 10 years. But think about it. Is every single tank the same? Of course not. It was just a best guess. The new way, what we call risk-based inspection, or RBI, is a total game changer. It throws that rigid calendar right out the window and instead says, let's use data to predict the future. It's all about being smart and proactive, not just punching a clock.
To really get how this works, we need to make a little mental shift. We're moving away from just reacting to a schedule, and instead, we're starting to think in terms of risk. It's a completely predictive approach to safety.
So what do we even mean by risk? It's not just some vague feeling of danger. In the world of engineering, risk is a very specific thing. It's a calculation that really boils down to two simple but super important questions. First, what are the chances this thing will actually fail? And second, if it does fail, just how bad is it going to be?
And that brings us to the absolute heart of the matter. This simple little formula you see here, this is the engine that drives the whole RBI process. Risk equals the probability of failure times the consequence of failure. It looks simple, right? But don't let that fool you. This is incredibly powerful, because once you can put a number on both sides of this, you can put a number on risk itself. You can actually measure it and track it over time.
All right, so let's pull that formula apart and look at the pieces. First up, we've got to figure out the how likely part. We call that the probability of failure, or POF for short. Basically, what are the actual odds that our tank is going to spring a leak?
So how in the world do you calculate something like that? It's not like you just pull a number out of thin air. This is where it gets really clever. The RBI models look at a whole bunch of different factors to get a very specific, tailored answer for each individual piece of equipment. Okay, this is how it's done. You can think of it as a three-step process. First, you start with what's called a generic failure frequency. This is just baseline data from thousands of other similar tanks out there in the world. It's our starting point. But then, and this is the key part, you adjust it with a damage factor. This is where we get specific about our tank. What's its actual measured corrosion rate? And finally, you apply a management systems factor, which basically asks, how good is this facility at safety? You know, a great safety culture actually lowers the probability of something going wrong. It's brilliant.
All right, so we've got a handle on the how likely part, but that's only half the story, right? Now we have to tackle the other side, the how bad. This is the consequence of failure, or COF. If that tank does fail, what is the full impact?
And impact isn't just one thing. Think of it like a stone thrown into a pond. A failure creates all these ripples. And RBI calculates the cost of every single one of them, from the direct repair to the effect on the environment.
And I mean, look at this list. The scope is just huge. You're calculating the cost to repair the tank itself, any damage to the equipment around it, the money you lose because your business has to shut down, and of course, the most important ones, the impact on people's safety and the cost of cleaning up an environmental mess. The system takes all of that, the whole shebang, and rolls it into one big financial number. That's your total consequence.
Okay, so now we have our two key numbers, probability and consequence. We've got both halves of our risk equation. Now comes the really cool part. We get to put them together and watch what happens over time. This is where the predictive power of RBI really starts to shine.
Right, because risk isn't just a snapshot in time, it's a moving picture. Let's go back to our tank. Every year that passes, corrosion is literally eating away at the walls, making them thinner. That means the probability of failure is going up. Slowly but surely. And since risk is just probability times consequence, that means the overall risk level for that tank is climbing, day after day, year after year.
And we can actually visualize this on a risk plot, just like the one you see here. So when the tank is brand new, it's sitting pretty down there in the bottom left corner. See that? Low probability, low risk. Everyone's happy. But as time goes on and that corrosion does its work, its position on this chart starts to creep. It moves up and to the right, going from low risk into medium risk and heading straight for high risk.
Of course, we can't just let the risk climb forever. That would be crazy. So, a company will draw a line in the sand. They define a safety threshold, a line on that graph that they decide must never, ever be crossed. This is their maximum acceptable risk target.
And here it is. This is the big aha moment. The RBI analysis projects that climbing risk curve into the future and tells us the exact date when our tank is predicted to hit that acceptable risk limit. And that is our inspection date. It's not a guess from a calendar anymore, it's a data-driven forecast. Pretty amazing, right?
So the analysis gives us a date, which is awesome. But the power of RBI actually goes even further. It helps create a truly intelligent inspection plan.
Yeah, we're no longer just showing up to, look around. All that data that we use to calculate the risk in the first place, it also tells us exactly what we need to look for and where we're most likely to find it. It makes the entire inspection far more effective.
So the final RBI plan gives you 4 critical things. First, the date, the latest safe day for that next inspection. Second, the what. It identifies the main problem you're looking for, like general corrosion in our tank example. Third, the where. It pinpoints the most vulnerable spots on the tank. And finally, the how. It even recommends the best inspection technology for the job. It's a complete strategy for safety.
This shift from just reacting to schedules to proactively managing a predicted future is a true game changer for industrial safety. And it really makes you wonder, doesn't it? If we can apply this logic to a storage tank, what other complex systems in our world could benefit from thinking about the future in terms of risk?